Okay. So in the last lecture, we have seen the method of preparation of phthalimide, and this was under the section in which carboxylic acid they were reacting with ammonia, है ना? So they form amide, but in the specific case of phthalimide, we get for in the specific case of phthalic acid, we get phthalimide. Now there are three more reactions left, right? The eighth one, decarboxylation reaction. And this, please write. What happens here is we start with carboxylic acid, that is RCOOH, and we add here NaOH. Obviously, acid and base, it will give you salt, that is RCOO negative and Na positive. Now, after this, the decarboxylation reaction really starts. So in this reaction, we take soda and lime. Soda is NaOH, lime is calcium oxide. Fine. So these are the two major reagents that we take. The reagents are soda, that is NaOH, plus lime, that is calcium oxide. ठीक है, तो soda lime लेते हैं and then we heat it. Now obviously you can see that we can skip the first step and we can directly do the NaOH plus calcium oxide. That would require a bit more of calcium, it will require a bit more of sodium hydroxide, but we can skip the first step also, है ना? तो जरूरी नहीं कि पहला स्टेप भी रहे, सीधा RCOH plus NaOH and CO दे दिया जाए. Fine. But NCERT has written the reaction in this way, so it is best if they ask directly decarboxylation reaction as they have asked in the 2024 examination of boards. तो उसमें as it is लिखिएगा तो ज़्यादा बेहतर है. And what you are going to get is RH. So if the carboxylic acid is having 5 carbon atom, I will get an alkane which is of 4 carbon atom, plus we get Na2CO3. ठीक है. Now in this case what happens? Please write with me. In decarboxylation reaction, it forms alkane with 1 carbon less than carboxylic acid. NaOH plus calcium oxide is also known as soda lime. Now, for example, here we have how many carbon atoms? Here we have 3 carbon atoms, and if you treat this with soda lime, NaOH, calcium oxide, and a bit of heat, then what we are going to get? We are going to get a alkane with 1 carbon less. तो यहाँ पे 3 कार्बन है तो 2 कार्बन का alkane मिल जाएगा, CH3 single bond CH3. If I have 1 2 3 4 carbon atom and carboxylic acid, the same thing, then we are going to get 1 2 3 carbon atoms, है ना? तो एक कार्बन कम. Copy this down, raise your hand if you're done. Waiting for Sophia. नाइन नंबर लिखिए, कोल बेस्ड इलेक्ट्रोलाइसिस. Start with carboxylic acid and we treat this with sodium hydroxide to make a salt that is RCOO negative and Na positive. After that, we do electrolysis. That means RCOONA, in which we can see you have an ion and you also have a cation. So we can do electrolysis. अब इसके electrolysis में क्या होगा? Now, in the electrolysis, what are the products that we are going to get? We are going to get RR plus NaOH and CO2. NaOH and CO2. ठीक है, अब ध्यान से देखिए जरा यहाँ पे. Now, this RR, it is formed. अच्छा, यहाँ पे how many carbon atoms by the way? You can see that R and C. ठीक है, तो we have double the carbon atom, but like for example, ऐसे मैं इसको लिख सकते हैं. I hope that makes sense. 2 into n minus 1. Here, what is n? The number of carbon atom in carboxylic acid. N is equal to number of carbon atom इन कार्बोक्सिलिक एसिड इन सी है ना. तो अगर यहाँ पे 4 कार्बन एटम है तो एक कम कर दीजिए, दैट इज 3, 3 टू द 6, 6 कार्बन एटम का एल्किन आपको मिल जाएगा. दिस यू आर गोइंग टू गेट इन द एनोड and this you are going to get in the cathode. And slowly you can see that because of the formation of NaOH, the solution is going to get slightly basic over the time as electrolysis keeps on going. ठीक है, तो और यहाँ पे सेम थिंग आपको बस यहाँ पे क्या लिखाएगा, इलेक्ट्रोलाइसिस. ठीक है ना. They will only give you electrolysis written here. What you are going to do? You are going to see how many carbon atom? 3 carbon atom. 3 में से एक माइनस करो कितना हो गया? 2. 2 का डबल 4. So 4 carbon atom का you are going to get an alkane. Alkane formed will have 2 into n minus 1 carbon atoms. N is equal to number of carbon atoms in carboxylic acid. आमना, you are quite late. आप यहाँ से लिख लीजिए आमना. The last reaction is the electrophilic aromatic substitution.
Okay, sir.
Now, in electrophilic aromatic substitution, we have seen these reactions, electrophilic aromatic substitution, in almost all of the chapters and multiple times. So, first of all, ortho product या meta product बनेगा. Please write, since carboxylic acid is a deactivating group, it would form meta product. meaning carboxylic acid. अच्छा, I am not just pasting it. Wait a second, है ना? Hopefully it would make sense. This makes sense? Yes or no? Please tell me, guys.
Yes, sir.
In nitric acid and H2SO4, it is going to get a meta product in the NO2 और यहाँ पर Br मिल जाएगा, ठीक है? It does not go Friedel Crafts reaction because इसको हम लिख देते हैं जरा. You can start writing, guys. Benzoic acid doesn't undergo Friedel Crafts reaction because carboxylic acid is a deactivating group and the catalyst AlCl3 gets bonded to COOH group. Basically, aluminum chloride, it is a Lewis acid. So what it will do, like, and the carboxylic acid, Lewis acid है तो क्या होगा? It will go and bond to wherever the electrons are present, है ना? तो carboxylic acid में electrons है, oxygen के पास वहीं पे जाके bond बना लेता है. और as soon as the carboxylic acid it will liberate its H plus ion, the negative charge will be present on oxygen और वहीं पे आके फिर LCl3 बैठ जाएगा to get its octet complete. Raise your hand if you're done. Waiting for Sufyan. Done. Okay, so this is the end of carboxylic acid also. So we can start our new chapter, that is amines. Chलिए, so you can write the heading amines. amine में first of all, if you have RNH2, then this is known as 1 degree amine. If you have R nitrogen, another R group, and then one hydrogen, then this will be known as the 2 degree amine. And if the nitrogen atom it is only attached with alkyl groups and none hydrogen, then this will be known as the 3 degree amine. And if there are 4 alkyl groups attached on the nitrogen atom, with the positive charge obviously because it has donated one of the electron pairs as its lone pair. तो ये हो जाएगा क्या 4 degree amine, and they all have their own name. So this is primary amine, this is secondary amine, this is tertiary amine, and this is quaternary. Ammonium ion है ना, quaternary है ये ammonium ion. Now after this we are going to directly look into the IUPAC nomenclature. ठीक है, bit of IUPAC nomenclature. Please raise hand if you're done. Done everyone? Great. In IUPAC nomenclature, जैसे अभी तो हम जनरली छोटी छोटी चीजें देख रहे हैं ना, तो फॉर एग्जाम्पल इफ आई हैव 2 कार्बन एटम्स एंड NH2, तो 2 कार्बन एटम को क्या बोलेंगे, इथेन. अमीन है ना. बट इफ यू हैव लेट्स सपोज 1 2 3 4 कार्बन एटम्स एंड NH2 इट इज इन द सेकंड कार्बन एटम, तो इसको क्या बोलेंगे, इसको बोलेंगे हम लोग ब्यूट एन 2 अमीन, और इट कुड ऑल्सो बी रिटन एज 2 ब्यूटेन अमीन. Okay, this is the more standard form, but this also works completely fine. There is nothing wrong here. Now, what I want you to learn in today's class is what if we have a 2 degree amine in which we are having 2 carbon atoms, 1 nitrogen, and then we have a CH3 group, and this nitrogen atom is having 1 hydrogen here. Now, what to do in this case? So, in this case, see, we have a format that we generally follow, that is functional group. So it is amine because here we have a nitrogen atom and उसके बगल में कोई और है नहीं है ना. There is no carbonyl or that, so that it would be amine. Cannot be amine. It cannot be amide है ना. It will be amine. So functional group is amine. Unsaturation, there is no unsaturation, so that is why this it's going to be AN. The parent chain. Now there are two chain here. This is one chain and this is the another chain. Now both of the chains are directly attached to the functional group. So we cannot decide on functional group. There is no unsaturation, so we cannot decide on the basis of unsaturation. Now the next criteria is the maximum number of carbon atoms. So maximum number of carbon atom, it is on the left side. And how many carbon atoms are there? There are 2 carbon atoms. है ना? So parent chain क्या हो जाएगा? Eth. Now whatever is left after the identification of functional group, unsaturation, and parent is the substituent. So we can see that this part is left. That is the CH3 is left. So that is going to be the substituent. So that is going to be methyl. Now here comes the important part. Where is methyl attached? In which carbon atom? It is not attached to carbon atom first of all. So how are we going to number it? So we don't number it. We actually letter it. इसमें हम लोग लिखते हैं N-methyl. N-methyl का मतलब हो जाता है that the methyl is attached on the nitrogen atom. And now you can write the name very easily. N-methyl ethane amine. चलिए, copy this down. Raise your hand if you're done. Waiting for Amna, Sufyan, and Taha. Just waiting for Taha. Last case, if I have something like this, है ना? तो इस केस में कैसे होगा? सो यू आर गोइंग टू हैव फंक्शनल ग्रुप दैट इज गोइंग टू बी सेम। इसमें हम डायरेक्टली बता देते हैं ना, बाकी सब चीज तो सेम होंगे, है ना? So this is butane, and there are two methyl on the nitrogen atom, so we can say that it's going to be N comma N dimethyl butanamine. After this, you can write the heading MOP of amine. Waiting for Amna. Yeah. Each of the method of preparation is very important, है ना? Right, the first one, that is the reduction of nitro compounds. इसमें the nitro compounds can be reduced by mainly two different reagents. एक तो हमारा बहुत ही पुराना साथी है, हाइड्रोजनेशन, है ना? So hydrogenation is one of the methods of reducing HO in the presence of PD and in the presence of ethanol. The other reagent is metal के presence में HCl, and this metal, it can be iron preferably, or it can be tin. दोनों केस में क्या होगा? The O2 will be converted to H2, NH2, RNH2. ठीक है? Now, for example, this also works if we are having a aniline, no, not aniline, but nitrobenzene. In order to make aniline, we have NO2. For example, if I add here Fe, the presence of HCl, then you are going to get NH2. ठीक है? Similarly, अभी सिर्फ देखते रहिए, उसके बाद लिखिएगा. This also works with aliphatic amine. Everything as it is, both the oxygen atoms are going to be replaced by hydrogen atoms. ठीक है? चलिए यहाँ तक ड्रॉ कीजिए पहले, उसके बाद I will write a point. Or maybe I can write the point here also. ना, you guys keep on writing, उसके नीचे लिखिएगा. And Fe plus HCl is used. FeCl3 is formed as byproduct, which is easily hydrolyzed. to release HCl gas. Therefore, only a small amount of HCl is needed. है ना? So what happens? We have Fe plus HCl. Then in that case, we get amine, and with amine, we get a byproduct on every reaction, that is FeCl3. Obviously, the complete reaction it is happening in a, you can say, in a aqueous medium. पानी के अंदर ही हो रहा होगा, because we don't have anything which is not going to be soluble in water. Okay. So now what's going to happen is that the FeCl3, which has been just now formed as a byproduct, it will get hydrolyzed and it is going to liberate H2 gas. Not H2 gas, my bad. It is going to liberate HCl gas. Now that same HCl gas can be reused in the reaction. So initially, we would have to take only a very small amount of HCl, because the HCl it is getting reformed again and again. Okay. Raise your hand once you're done. Waiting for Amna and Taha. Okay. So now, a very important point, which is, I mean, completely not there in the NCERT, but exemplar में इसके ऊपर सवाल है, ठीक है? So the point is, our one of the best reducing agent is lithium aluminum hydride. So if you have RO2, RNO2, and in the reagent we have lithium aluminum hydride, then in that case also we get amine, that is a 1 degree amine, RNH2. But if I do the same reaction with aniline, sorry, not aniline, from nitrobenzene, then we get a completely different product in which we have a benzene ring, which is having a bond with nitrogen atom, which is doubly bonded with nitrogen, then single bond, and then we have again a benzene ring. So obviously we get a azo compound, but we do not get amine, है ना? The main point यही है. There is an MCQ in exemplar कि which of the following reagent cannot be used for the reduction of nitro compounds to reduction of nitrobenzene to aniline. ठीक है, तो उसमें से एक ऑप्शन ये क्या है, लिथियम एल्यूमिनियम हाइड्राइड. ठीक है, तो इसको याद रखिएगा हमेशा. अराइल अमीन्स cannot be prepared by reduction of nitrobenzene with lithium aluminum hydride. Raise your hand, then we are going to move on to the next method of preparation. Okay. Right, next, reduction of nitriles. Now, in this, the for the reduction of nitriles, the reducing agent that we are going to use can be any one of these. You can use lithium aluminium hydride, or you can use H2. In the presence of, you can have nickel or palladium or platinum. Any one of these catalysts, any one of these metallic catalysts could be present. Or the last option is sodium amalgam, Na in the alloy of Hg, that is mercury, in the presence of ethanol. So any one of these reducing agent is going to convert RCN to R. This carbon will get two hydrogens and become CH2. The nitrogen will also get two hydrogens and becomes NH2. This would also work on benzonitrile. For example, if I have something like this, CN, then I'm going to get the benzene ring, the CH2 and NH2. Okay, so it's down. Now, what is in the arrow? Any one of these reducing agent ना ऊपर में जो हमने तीन reducing agent लिखे हैं उसमें से कोई सा भी हो जाएगा, then it's fine. Waiting for Amna. Third method of preparation is example लिखा है. चलिए ठीक है. Third method is reduction of amide. We start with RCONH2, that is amide. And the only reducing agent that you can use for the amide is lithium aluminium hydride. And you will get the same thing, RCH2NH2. कितने कार्बन एटम? चार कार्बन एटम. You will make the four carbon atom acids और उसी में wherever the amide was present that will get NH2. Oh my bad, wait a second, इसको NH2 कीजिए जरा. And this also works for benzene rings. Okay, raise the hand if you're done. Waiting for Amna and Taha. Just Taha is also done. Right, the fourth one, ammonolysis of alkyl halide. This we have haloalkane plus NH2 Now, as soon as this reaction happens, we get our NH3 positive and X negative, that is a quaternary. Now it is a salt, है ना, ammonium salt आ चुका है, amine का salt आ गया. Now after this we add NaOH. NaOH यहाँ से फिर एक हाइड्रोजन हटा लेता है, then you are going to get RNH2 plus water plus sodium halide, है ना. If it was chloride तो sodium chloride, bromide तो sodium bromide, and so on. Now the problem with this type of reaction is that the reaction starts. How does it start? The nitrogen atom attacks on the alkyl group. And why is the nitrogen atom attacking on the alkyl group? Because the nitrogen atom, it is having lone pair electron, and the alkyl group, it is attached with the electronegative element, that is chlorine, fluorine, bromine, or any one of these halogens. That is why the attack is happening. Now, if you see here, the nitrogen in the product, it is also having a lone pair, the same lone pair type of thing. और थोड़ा ध्यान से देखें, then if there will be any Rx, अब ऐसा तो नहीं ना, if I am going to have a billion and billion molecules of Rx, then all the Rx will simultaneously get converted to RNH2. Not all the alkyl halide is going to simultaneously be converted to amines. When some of the molecules have been converted to amine, there will be some Rx unreacted. Does this make sense? Yes or no? Please tell me. When some of the amine has been formed, there will be some Rx which is unreacted. That unreacted Rx can be attacked by the RNH2 once again. For example, reaction, how does it happen? Rx. Then here we have R. Let's suppose we have here R dash NH2. ठीक है, अभी तो बस एक R लगा हुआ है, या फिर इसको भी हटाओ. सिर्फ आपके पास क्या अमोनिया है. Then you will get RNH2. Some of the Rx will be still unreacted. So those unreacted Rx and the newly formed RNH2, it is going to again attack. You will get RNH. यहाँ पे क्या मिल जाएगा? R मिल जाएगा, और यहाँ पे क्या बचेगा? H बचेगा. There will be still some of them left. Then you are going to get again, there will be some reaction happening. And this type of compounds, not all of these 2-degree amine will be getting converted. Some of these will be getting converted to 3-degree, that is R and R. But still this is having lone pair, so the reaction can happen one more time, and you will get Rx. So यहाँ पे R, nitrogen, R, R and R with a positive charge here. ठीक है ना? Because this is going to be a quaternary ammonium salt, but this positive charge will be stabilized by the X negative, what is coming out from the Rx. Does this make sense? Yes or no? Please tell me. रिएक्शन समझ में आया क्या हो रहा है? बार बार Rx क्यों रिएक्ट कर रहा है? Yes or no? आमना सुख्यांतः.
Yes, sir.
Okay. Now, as you can see that you will get some of the product which is going to be a 1-degree amine. There will be some product which is going to be 2 degrees, some 3 degrees, and some 4-degree amine. That is why this method is not a preferred method of preparation. Please, you can write this method, this MOP gives a mixture of 1 degree, 2 degree, and 3 degree. And लिख लेते हैं ना, quaternary salt भी तो है. And quaternary ammonium salt. Therefore, it is not a preferred MOP. Waiting for Amna. चलिए. Now, now we have to think: is there any way in which we can get a major product as the 1 degree? Major product as 1 degree. I mean, so yes, there is a method in which we can what we can apply here is, see, 1 degree I mean तो हमको चाहिए, so I cannot do anything to that. But what I can do, I can eliminate the Rx, है ना, एक ही बार में majority of the Rx क्या हो जाए, react कर जाए. So in that case, what we have to take, we have to take ammonia in excess. NH3 should be in what? It should be in excess. Too much ammonia will be there. So almost all the haloalkane, all the Rx will be reacted and it will be getting converted to RNH2. The majority of them are getting converted to ना बहुत कम unreacted बचेंगे तो फिर further reaction होने के chances कम हो जाएंगे ना. So we can say is to get 1 degree amine as major product, ammonia is taken in excess and if we talk about the reactivity of the haloalkane, then obviously the alkyl iodides are what? Fastest, followed by alkyl bromide, followed by alkyl chloride and alkyl fluoride तो generally use भी नहीं करते but फिर भी सबसे कम alkyl fluoride का है. Why? Because the Ci bond, the carbon iodine bond is weaker and it is going to easily break. तो ये पहले ये bond टूटेगा RS वाला bond तभी तो RNH2 लगेगा, है ना. तो this is the bond, this is the redetermining step. यहीं पे आपका redetermine होता है, ठीक है, the breaking of RX bond. So if they have given something like this, then just take two carbon atoms and replace the Br with NH2. And इसमें एक चीज ध्यान रखिएगा जरा, that this reaction is not going to work if you are going to have a haloarine, because this is a nucleophilic substitution reaction है ना. इसमें देखिए nucleophile attack कर रहा है, obviously, and this nucleophilic substitution is not given by haloarine. तो यहाँ पे लिख लीजिएगा, for example, some halogen, and here I have ammonia. In no matter how much excess of ammonia we are having, this will not give any significant product. That is why we are going to write no reaction. तो एक और पॉइंट भी आ जाएगा, as haloarine don't show SN, therefore aniline cannot be formed by this method. Raise your hand if you're done. Waiting for Amna. Right, next, quite an important synthesis that is known as Gabriel phthalimide synthesis. Gabriel phthalimide synthesis. Now we have already seen what is phthalimide. Nitrogen, and here we are going to have hydrogen. अब इसमें सबसे पहला स्टेप ये है कि you are going to add KOH, potassium hydroxide. Now please see this particular hydrogen atom. If I am going to remove this hydrogen atom, this nitrogen will get negative charge, which can show resonance with the oxygen atom in the above and oxygen atom in the blue also. So this hydrogen of the phthalimide, it is quite acidic in nature. So when we add base, it is going to be very quickly replaced. यहाँ पे नाइट्रोजन का क्या बन जाएगा? Wait a second. Nitrogen, and here you are going to have K, that is potassium. ठीक है, और ये can write N negative and K positive, N negative और K positive भी लिख सकते हैं आप. Now here comes the main reaction in which haloalkane is added. Now you can see that the nitrogen atom, it is having a negative charge, haloalkane में positive होगा ही, so this nitrogen atom is going to attack on the halo. अब haloalkane यहाँ पे अटैक करेगा, X निकलेगा और यहाँ से K निकल जाएगा, so here I am going to write minus KX. If this halogen is chlorine, it will be potassium chloride and bromide and so on. अब आपके पास प्रोडक्ट क्या बनेगा? Now this nitrogen atom, in place of having potassium, it is now having what? It is now having the alkyl group R. Whatever alkyl group we have started from the haloalkane, halorine. Not haloarine, rather haloalkane only. After this, you can add NaOH, and this does the work, and we get this product. O negative and O negative. Obviously, we are having basic medium, so Na or Na plus we get our product, our desired product, that is RNH2, which is a 1 degree amine. ठीक है, so we can say that the GPS, that is Gabriel phthalimide synthesis, it is used for preparation of 1 degree amines. Next point, aromatic amines or aromatic 1 degree amines cannot show or cannot be formed by Gabriel phthalimide synthesis, as aryl halide don't show SN. Waiting for Amna. Okay, done. Now, the last one is Hoffman bromide degradation. Hoffman bromide degradation क्या होता है इसमें? First thing is that R, जिसमें क्या क्या reagent रहेंगे, तो brom amide, you can see that that means we are obviously going to have a amide group, प्लस ब्रोमीन भी होगा Br2, है ना, ब्रोमाइड है तो। और सुनिए, हॉफमैन का ना OH रहना चाहिए, है ना, ठीक है। We have got all the three main reactants that we require in Hoffman bromide degradation. The amide we have got bromine and some OH. So for example, you can have NaOH or KOH, anything, doesn't really matter, and this would give you RNH2. Now why it is degradation? Because what is happening with the number of carbon atoms? We are having one carbon less in the product side. So in this case, what are the reagents and how the reagents are going to look? That is also quite important. So the reagent may be Br2 plus KOH or NaOH. It doesn't really matter. You can have any one of them. Now, what's more important is that rather than writing this whole thing Br2 plus KOH, they are only going to write we get a particular product after we add halogen and acid, that is KOBr or NaOBr, KOBr or Na sodium hypobromide. Okay, so any one of these reagents could be given, and the product amine will have one carbon less than amide. Okay, so for example, so here they have given sodium hypobromide. Now what you have to do? How many carbon atom? 4. तो एक कार्बन कम करके बस अमीन बना दीजिए, 3 कार्बन कर दीजिए, CO हटा देना बस आपको ना, 3 कार्बन और सीधा NH2. This would also work in benzamide, CONH2, same reagents, and you are going to get directly aniline. CO बस हटा देना है आपको. Waiting for Amna and Taha. Okay, everyone is done. The MOP is over with Hoffman bromide degradation. The next one is physical properties. Now, a very important distinction between 1 degree, 2 degree, and the 3 degree amine is that 1 degree and 2 degree, both of them, they are able to make hydrogen bond with themselves. Similarly, the 2 degree one are nitrogen, R, and then one H. So here also it can form hydrogen bond. So both of these, that is 1 degree and this is 2 degree, both of these can form hydrogen bond. But if I have a 3-degree amine which is completely surrounded with only alkyl groups and there is no hydrogen directly attached here, so this will can never form, cannot form hydrogen bond. Okay. So that means whatever we are going to talk about, like in the physical properties, it mostly depends on the intermolecular forces of attraction. And in this case, the most dominant intermolecular force of attraction should be hydrogen bonding. But the 3-degree amines, they do not really show hydrogen bonding. So we are not going to, we are going to consider the 1-degree and 2-degree, and they're going to have like significantly different physical properties than the 3-degree one. ठीक है, तो साथ साथ लिखिएगा मेरे amines except 3-degree है ना, have higher boiling point than corresponding hydrocarbons. And polar molecules. Next point, boiling point of amines is less than alcohol and carboxylic acid because hydrogen bond in alcohol and carboxylic acid is made by more electronegative oxygen. इस वजह से इनका अमोनिया, दैट मीन्स अमीन्स का हाइड्रोजन बॉन्डिंग जो होता है, इट इज नॉट एज इफेक्टिव एज द हाइड्रोजन बॉन्डिंग ऑफ oxygen in alcohol and carboxylic acid. Huh? So that's what we have seen here. The boiling point of amine is less than alcohol and carboxylic acid because the hydrogen bond in alcohol and carboxylic acid is made by more electronegative oxygen atom. Raise your hand if you're done till here. All of you done? Next point. Now, we have seen amines, hydrocarbon, polar molecules, and alcohol, carboxylic acid. What about in between amine? So, in between amine, the 1 degree will have the highest boiling point because you can write since 1 degree amine has or can form two hydrogen bond, two hydrogen bond. Therefore, it has highest boiling point, but amongst amines only, है ना? Amongst amines. तो 1 डिग्री का सबसे ज्यादा, उसके बाद 2 डिग्री का, और 3 डिग्री का तो बहुत ही कम होगा बिकॉज 3 डिग्री कैनॉट फॉर्म हाइड्रोजन बॉन्ड. नेक्स्ट पॉइंट, amines are soluble in water. Amines are soluble in water as they can form hydrogen bond with water. Next point, as we have seen from the alcohol chapter, that the solubility decreases on increase in number of carbons. Last point, in the physical properties, aniline is not soluble due to bulky benzene ring. Last point, if I talk about the solubility, then in this case, alcohols are more soluble than amines. है ना? The reason is same, since hydrogen bond in alcohol is made by more electronegative oxygen atom. So this is all in the physical properties. Now we have only one thing left, that is chemical properties. All the chemical properties और उसके बाद फिर डाइजोनियम सॉल्ट भी हम लोग करेंगे. Let me know if you're done. Waiting for Amna. Okay, Amna is also done. Now you can write the heading chemical properties. Now, in chemical properties, the first chemical property is very important, that is carbyl amine reaction. एक तो ये नेम रिएक्शन हो जाएगा, है ना? Carbyl amine reaction. What happens here is, now the complete reaction is very important. All the reagents and all the products. We have a 1 degree amine, and we react this with chloroform plus potassium hydroxide. And that means in basic medium. When you heat this, you get RNC. Now, what is RNC? It is alkyl isocyanide. And this isocyanide, it has a very foul smell, a very bad smell. So if you have added something, if you have added chloroform and aqueous KOH into something and it gives a very foul smell, that means the compound is having a 1 degree amine, maybe aromatic, maybe aliphatic. KCl plus H2O. So you can write aromatic or aliphatic primary amines react with chloroform and KOH at elevated temperature to form alkyl isocyanide, which has a very foul smell. Last point in this reaction is used as a test for 1-degree amines. Waiting for Amna and Taha. ओके, चलिए तो आज के लिए हम लोग इतना ही रखते हैं एंड द रेस्ट ऑफ द केमिकल प्रॉपर्टीज ऑफ अमीन as well as diazonium salt will be completed in the next class. ठीक है, and